Question 3, Part A. We are given a table here with 5 statements in this first column here, and we need to indicate whether these statements are true or false in reference to the Venn diagram that we're given in the question, which I've drawn out here on the left. So let's just have a look at this Venn diagram for a second. We have 4 sets, A, B, C, and U. So this A circle, the B circle, and you'll see there's a shared area between the A and the B. We have a C kind of circle, a squash circle, and then they're all within this greater set, which is U. And we are also given the information that X is an element of U. Well, at first glance, I could also say, well, X is also an element of A and B as well as U, but not C. See how X is in the A circle and X is in the B circle, and it's also within this full boundary U, so it's also an element of A and B. Now, in order to answer the true or false column, we need to understand some of these Venn diagram and probability symbols, and I've written them out here, the key ones we need to know in green. And we'll reference these as we go through these one by one. So let's work them through. The first one asks, X is an element of C. So I'm just going to write out what these mean. X is an element of C. That's what this means in words. Now let's go see if this is true or false. Well, X does not live within the C circle, squash circle. It's within the A and the B, but not C, so this is false. If there was an X down here, then that would be true, but it's not. It's not within that circle. Second one, X is a subset of B. Now, at first glance, you may think, well, that is correct because X is within the B circle. However, X is not a set. X is an element. In the question, we are given that there are 4 sets, A, B, C, and U. So X can't be a subset because it's an element. So therefore, this one here is false. Just to go a bit further on that, with Venn diagrams and probabilities, you have sets. So let's say a set is A, and you have a whole bunch of elements that live within inside it. So let's, for example, X, Y, and Z. These are the elements, and this is the set that houses the elements. Next one, A union B does not equal an empty set. Now, what that means, I guess, in English is A or B is not an empty set. So A or B, and then is not or is not equal to an empty set. So let's have a look at our Venn diagram here. A or B is not an empty set. It's a bit of a double negative, so it's a bit of a hard one to understand here, but the answer to this one is true because A or B does have an element within it, which is X. So it is not an empty set. That is true. Fourth one, A and B is a subset of C. So this is an intersection symbol. So A and B is a subset of C. Now let's have a look at our Venn diagram. A and B, they don't live within the C circle. They are their own complete sets. Now A and B is a subset of U because the circles are within this U square. However, they're not a subset of C. Likewise, C is not a subset of A or B as well. So this is false. And finally, A and C A or C, apologies for that, I thought I had this written down incorrectly for a second then. This is A and C is equal to an empty set. So in other words, A and C is an empty set. And I'm also going to write this as the intersection of A and C is an empty set. Okay, let's have a look at this. What does this mean on the Venn diagram? Where is the intersection of A and C? Well, there isn't any intersection. They don't cross over in any way. The intersection of A and B is here, and this is not an empty set because there is an element X within it. However, the intersection of A and C is an empty set. There is no element that lives between these 2 points. If they did happen to, say, cross over here, like that, and there was an element in here, then it wouldn't be an empty set. However, the intersection of these two, there are no elements within it. So that is actually, this statement here is actually true. And there we have it. We have completed this statement table.